Good evening, everyone. I hand it over to Professor SreeKeshava, sir. It is 6 p.m. and we can start the class now.
Thank you, sir.
Thank
Good evening, students. So last class, what we discussed, it's more or less theoretical aspects related to strength of materials. And also we discussed regarding how the material property differs in various way, especially what is mean by main theoretical things like elasticity, plasticity, and stress strain curves and all. Now in this particular class, we will discuss regarding in little bit in detail thermal stresses, because in your PWD syllabi they have specifically mentioned the particular part thermal stresses. So it plays the thing is main aspects in your examination. So that's why I'm focusing on that particular topic in detail, and also we'll discuss a few problems related to that particular things, and also afterwards we move on to elastic constants, and also two-dimensional stress analysis. It is principal stress and principal strains. So shall we start? Yes, Ella idirappa, start ಮಾಡೋಣ.
Yes, sir.
Any doubts in last class?
Yes, sir.
Last class ನಲ್ಲಿ ಏನಾದ್ರು doubts ಇದೆಯಾ? ಏನಿಲ್ಲ? Okay, start ಮಾಡೋಣ. Okay, thank you. Yes, the screen is visible. Screen ಕಾಣಿಸ್ತಾ ಇದೆಯಾ?
Yes, sir. Yes, sir.
Okay. Yes. In this particular class, we will deal with thermal stresses. Yes, any idea what is meant by thermal stresses? What is meant by thermal stresses? Any basic idea? The stress means, you know that this is the change in property, which means the load resisted per unit area, P by A. It's a basic definition. So inherent property. What is meant by thermal stress?
By the application of heat.
Heat. Only by the application of heat?
It's temperature, sir.
Yes. The thing is, this is the stress induced due to temperature. Whether if you're giving temperature in a manner that, say for an example, you are having a member, this member is subjected to temperature. This is having the ability to expand. Say for an example, generally the temperature may be around 25 degree or some whatever thing. It rises to 50 degree. What happens? The material will
Changes its
expand.
dimension.
The material will expand. The thing is, because of temperature change, the material is having the property to expand or contracts. The thing is, if the same material from 52, it will come back to 20 degree. What happens?
Contract.
It will contract. The thing is, because of temperature variation, the material may be expand, or because of variation in temperature in decreasing manner, it may contract. So the thing is very clear that there's a variation in the materials because of thermal, because of temperatures. So in this particular aspects, you have to remember that there are two things. The one thing is free expansion. That is when we are getting free expansion. See, the member, if the member is fixed at only one end, if is a member, is a material or member is subjected to fixity at one end, it's just like a cantilever member. When this member is subjected to temperature, what happens? It will getting expansion. Say the original length of the member is L, and the change in length is, what is change in length?
Delta.
Change in length is DL. DL. Now, generally, for this kind of member, the DL or delta L is given by alpha LT, where alpha is coefficient of, what is alpha? Coefficient of thermal expansion, where alpha is coefficient of thermal expansion, where L is, what is L? Length of member, where T is temperature variation. See, what happens generally, the temperature may vary from 20 to 50. So in this case, what is T1? T1 is 20 degree, T2 is 50 degree. Then what is temperature variation? T equals T2 minus T1. T equals T2 minus T1. So generally the change in length can be expressed as alpha LT. So because of temperature, one important point you must note in your mind that when it is having free expansion, there is no thermal stresses. The thermal stress induced in the material is 0. Generally, you are getting these kind of questions. If the material is having free expansion, what is the stress induced in the material? So don't calculate any other things and all. Directly you write stress is 0 because there is no resistance. It will just, there's no resistance offered to create a stress. It's free to expand. That's why whatever the sigma stress at free expansion, the case one is free expansion. At that case, that is sigma is 0. Then we move on to the second very important case, which means, what is this case? What is this? The thing is, both ends are fixed. What it indicates generally, if I'm doing fixity at both the part, what happens? Any idea?
No changes.
There is no expansion. There is no expansion. This is free expansion. This is no expansion. So no expansion. What it indicates? Generally, the delta L, whatever the delta L is alpha LT only. Right? Then what is your strain? What is strain? What is the definition of strain?
Length of original length.
That is delta L by L. So alpha LT divided by L. What happens? L will get cancelled. What is the strain? L equal alpha T. L equals alpha T. Next, similarly, if you want strain, this is strain, you got strain. If you want stress, see, in free expansion, the stress is 0. But in no expansion, you are having to get the stresses. Why? Because of inducing of reactions. Because reaction will exist at fixed ends. Right? So, what is the basic definition of Young's modulus? What is E? This is the ratio of stress by strain. So, you know strain. So, what is sigma? Sigma equals E into E. So, E into what is small e? LT. So, what is sigma thermal? What is thermal expansion? Alpha ET. Alpha ET. So, you must remember the very important aspects in thermal stress part. The first is, what is the thermal stress? What is the thermal stress at free expansion? What is the thermal stress at free expansion? 0. Very good. Is 0. Next, what is the change in length? What is the change in length? Delta L. What is the change in length? Delta L.
Alpha into T into L.
Alpha into T into L or alpha LT. What is strain? What is strain?
1.2 T.
Alpha T. Strain is alpha T. And what is sigma thermal? At no expansion. At no expansion. What is the value?
Alpha ET.
Alpha ET. Please keep in your mind, these are the very, very important points. These are the very, very important points related to thermal stresses, related to thermal stresses, related to thermal stresses. Any doubts? Any doubts? Depending on this, you can expect numerical. Depending on this part, you can expect numerical as well as a theory part. Theory is very simple. As I told that theory, you may expect this question at free expansion. What is the thing? And also you can directly get the thing is what is the strain if the both ends are restrained with the fixed support, and what is the thermal expansion stress due to no expansion. This is the thing you can directly expect in your MCQ question, or relevant numerical you may expect. And also one more thing, what is compressive stress? Compressive stress, generally there are two terms, compressive stress and tensile stress. See what happens if the material is like this, fixed at both ends. If this material, say for an example, initially 20 degree, afterwards it will rise to temperature to 50 degree. What happens inside the material? Yes.
There will be compression.
Yes, it's in compression. But my question is, if the material subjected to initially T1 is 20 degree and it is rising to 50 degree, what is the mechanism you may expect inside the material? It is
Thermal stress is increasing.
increased, which means materials try to what? Expand. Because of this fixed support, what happens? There is a
Compression.
reaction. In which direction? See,
Opposite direction.
opposite direction. Similarly, this case also, the materials try to expand in this direction, but it get a
linear expansion.
See, it is trying to get resist in which direction? This kind of nature of force is called what type of force?
Compression
Kind of
force.
force.
Compression force.
Compression. See, this is compression stresses. Compression stresses. So the thing is clear. Compression stresses are responsible, are created because of
Thermal
expansion,
stresses.
rising temperature. Because of rising temperature. Please keep in your mind. Don't get confused. Okay. Similarly, if the material is subjected to contraction, what happens? Contraction means,
Decrease in temperature.
right? Decreasing in temperature. That it may be 52.
Video
struck
ಆಗ್ತಾ ಇದೆ.
ಏನಾಗ್ತಿದೆಯಪ್ಪ?
Struck ಆಗ್ತಿದೆ sir.
Yes. All are facing the same problem.
No sir.
Yes. Like in the internet, once check madama. Okay. Okay. So here, which type of resistance will develop? Because
Tension.
this is tensile. There is a tensile, right? So this is because what happens? Because of reduced temperature. Reduced temperature. This is because of increased temperature.
Compression stresses induced.
Yes. Tensile stresses. See, this is very, very important thing. The aspect is clear. So generally at free expansion, you're not having temperature stresses. You are getting only displacement, that is delta L. You are getting only delta L displacement. Clear? The concept is clear. Shall we move on to problems? Okay, concept clear, Aitappa? Please, yes, sir. Please take down these three equations. That is sigma thermal at free expansion is 0. Change in length is alpha TL, and strain is alpha T, and sigma thermal at no expansion, you are getting alpha ET. Now you may expect very, very important questions. Very, very important questions. Very, very important questions like we'll move on to the numerical MCQ part. Yes. Yes, this is a very simple question. The creep strains are due to. What is the reason for creep? Yesterday we discussed, I think, 5 questions. What is the reason for creep? Yes, I will come
Causes
to.
due to the both dead load and live load.
Yes, dead load or live load is right.
Only
Any others?
dead.
Others?
Only dead load.
Only dead load, right? Okay. 6th one. Consider the following statement regarding the tensile test diagram for carbon steel with varying carbon contents. See, you are having different materials. Each material is having carbon content. So you are getting, the thing is, if you increase the carbon content in the material, what happens? The first option is the ultimate strength of the steel decreases. The elongation before fracture is increases. The ductility of metal decreases. The ultimate strength increases. What will carbon contribute to material?
Ductility of the metal decreases.
Yes, right. Ductility of the metal decreases. If ductility of the metal decreases, what is the next thing? What happens next? Others?
Elongation before the fracture decreases.
I will give the codes. Yes, please pick the right answers. Yes, Helbeko, what is the right answer? 1 is right, the ductility of metal decreases, right? So the option, you are getting 3 and 4 and 1 and 3. You have to check with 1, the ultimate strength of the steel decreases, never. If the carbon content increases, what happens? The ultimate strength increases. The
Ultimate strength
increases.
increases.
Therefore, the options are 3 and 4. The options are 3 and 4. The options are 3 and 4. Next question. The creep strains are due to. What is the responsible for creep strain? Yesterday class we discussed regarding creep. What is the responsible for?
Dead load only.
Dead load.
Live load.
Dead load and live load. Others?
Only dead.
Only dead load, because I already several times I told in yesterday class, creep is the phenomenon. It's a long-term deformation because of self-weight. Because of self-weight. Self-weight matlab, that is, it's dead load only. Dead load. Okay. So answers. That is dead load only. So please keep in your mind. It's dead load. Yes. A steel rod, so this is related to temperature stresses. A steel rod of length L and diameter D, fixed at both the ends, is uniformly heated, at a temperature rises to delta T. The Young's modulus E and coefficient of linear expansion is alpha. Then what is thermal stresses in the rod? Yes, what is thermal stresses in the rod? It is mentioned that both ends are fixed. It's the second case. What is
0.
thermal stresses? Yes, what is the option?
Option 3.
Option 3.
3.
Because we know that the thermal stress is, what is the equation? E alpha T.
Alpha
Here T, instead of T, what is given? Delta T. Delta T is what? Delta
Change in
T.
temperature.
Yes, it's a temperature variation. That is, it may be T2 minus T1 or T1 minus T2, whatever. It depends on expansion and contraction, right? So that's why the answer is 3. The answer is 3. Any doubts? Any doubts? Clear? It's a direct question. Like this kind of question, you can hit in a single by thinking. You can write directly. Okay. Now, yes, a bar of cross-sectional area is given, and also is asking to compute the value of stress in segment QR. Yes, any idea how to compute this thing? Any idea?
Yes, sir.
Yes, how? please explain the thing like how you may just yes, I will take this. Okay. So initially the thing is you must keep each and every segment in equilibrium. Each and every segment in equilibrium. So here there are 3 segments. Here there are 3 segments. Here there are 3 segments. So the screen is visible. ಕಾಣಿಸ್ತಾ ಇದೆಯಪ್ಪ ಸ್ಕ್ರೀನು?
Yes, sir.
There are 3 segments, right? So in which we want the segment QR. We want the segment QR. First, I will take this part. What happens here? This is 21 kilonewton. So how to compute this part? If you apply sigma h equals 0, this is the sign convention. What is sign convention? Right side acting forces positive, left side horizontal forces are negative. So this is plus or minus? Minus. So minus 63. This one plus or minus?
Plus.
Plus 35. This is plus or minus?
Plus.
Plus 49. What is the answer? How much you are getting? 21 only you have to get, right?
Yes, sir.
Are you getting 21?
Yes, sir.
21 kilonewton. Now, if you come to this particular member, next member, because he is concerned about QR portion. For this QR portion, first you take this minus 63 plus 35. How much you are getting? ಎಷ್ಟು ಬರ್ತಾ ಇದೆ?
It will be 28.
Calculators ಎಲ್ಲ ಯೂಸ್ ಮಾಡಬೇಕು. This is a numerical subject. ನಿಮಗೆ ಎಲ್ಲೋ ಇರುತ್ತೆ ನೋಡಿ ಕೊಡ್ತಾರೆ. ಎಷ್ಟಪ್ಪ? 28, right? You are getting 28 kilonewton. Here also the same thing. Here you are getting 49 minus 21. 49 minus 21, how much? It's also 28. Now, what is stress? Stress equal load by
Force by area.
Force is 28 kilonewton. It's in kilonewton. The answer is in MPa. So you have to convert this value into Newton. So easily you are getting P value is 28 into 10 power 3 divided by area. Area is given as 700 mm square. Okay. Now what is the answer? How much you are getting? How much? 28 into 10 power 3 by 700. 7 4s are right. 40 MPa are you getting? How much?
40.
Yes, 40 MPa. What is the answer? Answer A. Option A. So this particular section is not required. This thing you have to you just don't do this part. If you want RS, then what is RS? 21 into 10 power 3 by area is given as 700. You are getting sigma RS. This is sigma QR. If you want sigma PQ, 63. If you do this equilibrium, plus 35, plus 49, minus 21, you are getting 63 only. Therefore, 63 into 10 power 3 divided by 700 will give sigma at PQ section. Any doubts in this kind of problems?
No, sir.
Any doubts?
No, sir.
Clear?
Yes, sir.
Okay. Okay. Next. Yes, this is also very, very important thing. Yes, the ratio of stress induced due to sudden applied load to stress induced due to gradual applied load of the bar is. Any guesses? This is straightforward, direct. Any guesses? The ratio of suddenly applied, that is impact. The ratio of impact load, stress due to impact, stress due to gradual. It's in BMT laboratory related things. Yes, any guesses? How much? What is the value?
1.5.
1.5. Okay. Any others? Okay. Let's see. The thing is,
2.
you must keep in your mind while you are solving these kinds of problems, what is the stress induced due to sudden load? Due to sudden load. What is the stress induced due to sudden load? And what is the stress induced due to gradual load? Gradual load. See, this is more or less related to your strain energy concept. So I will give direct equation. You just remember the direct equation. And if they ask, what is the stress due to sudden load? What is the stress due to impact load? What is the stress due to gradual load? You can directly write this equation. This is 2P by A. This is P by A. What is the ratio? Ratio of sudden to ratio of gradual. What is the ratio? Yes, what is the ratio? P by A can cancel. What is the answer?
2.
2. Please keep in your mind. Please take a note on this. The impact stress is 2P by A. You are doing while doing this particular thing, right? In your laboratory experimental part, using impact test for RM 90 degree, you are lifting the thing. You are getting the twice the P you have to take because energy absorption is more. Clear? Any doubts? Any doubts? ಗೊತ್ತಾಯ್ತನಪ್ಪ ಇದು ಕೇಳ್ತಾರೆ ಈ ತರ ಕ್ವಶನ್ಸ್ ಅಲ್ಲೇ ನಿಮ್ಗೆ ಏನಾಗುತ್ತೆ ಸುಮ್ಮನೆ ಗೆಸ್ 1.5 ಏನಕ್ಕೆ 1.5 ಬರ್ತದೆ ಸಡನ್ ಆಗಿ ನಿಮ್ಗೆ ಏನಂದ್ರೆ 1.5 is very familiar in civil engineering because of partial safety factor and all. So do, and also there is an Z value in steel structures and all that we are generally taking 1.5. Don't blindly follow the things. Keep in your mind for stress due to impact, it is sudden 2P by A, it's a gradual P by A. Clear? Shall we move on to next question?
Yes, sir.
Okay. Yes. The thing is, in terms of bulk modulus K, modulus of rigidity, okay. This is this question is related to your elastic constants. I will take this question later on. It's very simple questions. Okay. Now we will just move on to the part related to temperature stresses. Temperature stresses. Okay. This question is related to temperature stresses. It's a numerical, very, very interesting numerical. And yes, we will go with this second 13th question. 13th question. This is very good question. This is later on we will come, no problem. Okay. Yes, this kind of problem we are already solved in the previous problem. So here in previous problem I asked it to determine the stress. In this problem is asking to determine P. Yes, please guess. It's in 1 minute. 1 minute. Just by looking only you can tell the answer. Please get the answers.
20 kilonewton.
20. Others?
20.
20. Okay. Allah telling 20. Let's please check. If you apply sigma h equals 0, so minus 50 minus P plus 30 plus 40 equals 0. So minus 50 plus 30 will give minus 20 and plus 40 equals P. So P equals 20 kilonewton direct. See, for the confusing you people, this is mm square, given like 800, 200. What you are doing, that thing is this area is given, so we have to doing something with that area. All will do like that. So don't see, the thing is, if the question is right, you write it in a single step. You are getting nothing to worry about the things. Clear? Any doubts? Any doubts in this kind of problem? Any doubts?
No, sir.
bar subjected to varying cross section, bar subjected to same cross section, like that kind. Okay, yes, this is very, very important problem. This is related to temperature stresses. Please read the problem carefully and tell me the answers. Try to tell me the answers. Okay, here, okay, well, before going to 14 problem, it's a little bit tricky one. So that's why I will go to very easiest problem beginning. So afterwards, we can come to that particular problem. Okay, this is very good. Question number 22 is very good. Okay, this is related to temperature stresses. Please read the question carefully. Here, rails are laid such that there is no stresses in them at 24 degrees centigrade. If rails are 32 meters long, what will be the stress in the rail at 80 degrees centigrade? Or what is there is no alliance for the expansion if coefficient of linear expansion and E value all are given. Okay. Okay. By seeing this question, which equation is coming in your mind? I have given 3-4 equations, right? In thermal stress concept. Which equation is running in your mind? Your equation. Yes.
Alpha
Alpha
delta T.
LT.
So the main thing is stress, right? Stress equals sigma equal alpha
LT.
alpha LT. Alpha LT correct ಆಗಿ ಹೇಳಬೇಕು. Alpha LT ಏನಕ್ಕೆ, alpha ET ಏನಕ್ಕೆ, ಇಲ್ಲೇ ಕನ್ಫ್ಯೂಷನ್ ನಿಮಗೆ. Yes.
Alpha ET, sir.
Yes, alpha ET. Don't confuse alpha ET. So now
No.
alpha is given, right? E is given. T. What is T? T is here.
Change in
initially-
temperature.
Yes, temperature variation. Initially, how much the temperature?
Before
24 degree. It rises to
80.
80. Therefore, T equals, what is T? 80 minus
24.
24. T2 minus T1.
56.
T value?
56.
56. Now, here, see, rails. Railway ಕಂಬಿಗಳು ನೋಡಿದಿರಲ್ವಾ ನಮ್ಮ ರೈಲ್ವೆ ಕಂಬಿಗಳು 2 rails ಈ ತರ ಇಟ್ಟಿದ್ದಾರೆ. There is no free expansion. So this is rail 1, this is rail 2. There is no free expansion. The rail is having length of how much? 32 meters. 32 meters. L is given as 32 meters. Now, what is the stress induced inside the material? So just substitute the values. Sigma equals, and also please careful with units. Careful with units. Here centigrade, okay. Here it's also Celsius, okay, no problem. GPa. Now, what do you deal with this? E value. GPa means what? Gigapascal. What is a gigapascal? So 200
It's 10 to the power
10 power
9.
9 Pascal. See, Pascal means 1 Pascal is 1
1 Newton per meter square.
the square. So keep in all values like what is unit here. The length is also in meters, so I put it in Pascal. If it is length in millimeter, what is the case?
kilonewton per mm square.
Yes, on that case you have to put it in MPa,
Yes,
Newton
sir.
per millimeter square. Clear? Any
Yes,
doubts? Okay. Now you just substitute here. What is alpha? Alpha is 11 into 10 power minus 4. What is E? 200 into 10 power 9. What is T? 56. What is the value you are getting? Please tell me. Sigma
26.28.
20. Estapa?
0.28.
126.28. What is the option?
V.
D.
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 So sigma you are getting 120.28 MPa. Any doubts? This is very, very interesting and simple problem. Any doubts?
No, sir.
By keeping a 3 or 4 equation in your mind, you can crack it easily. Okay. Let me move on to next question. Fast adre helbeku. Let me move on to next question.
Yes, sir.
Others.
ಸರ್ ಫಾರ್ಮುಲಾ ಇನ್ನೊಂದ್ಸತಿ ಹೇಳ್ತೀರಾ ಸರ್?
ಯಾವ್ದದಪ್ಪ ಈ ಟೆಂಪರೇಚರ್ ಸ್ಟ್ರೆಸಸ್ ದಾ?
ಇಲ್ಲ ಸರ್, ಇದನ್ನ ಹೇಗಿದೆ, ಯಾವ ಕಂಡೀಷನ್ ಆಲ್ಫಾ ET ಮಾಡಿದ್ರಲ್ಲ ಸರ್ ಇದು?
Okay. See, you just, while we are solving temperature stresses, you keep whatever the 3 equations you keep in your mind. That
Yes,
is
sir.
first one, change in length. Delta L equal alpha LT.
Yes.
Okay, alpha LT. But stress equal alpha ET.
ET.
Stress equal alpha ET.
ET.
And strain equal alpha.
Alpha.
ಇದು 3 equation ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ.
Okay, sir.
Okay, ಈ 3 equation ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. Where T represents, that is the variation in temperature. T ಅಂದ್ರೆ ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿರಲ್ಲ. ಎರಡು ಟೆಂಪರೇಚರ್ ಇದ್ರೆ ಅದು ರೈಸ್ ಆಗ್ತಾ ಇದೆಯಾ ಫಾಲ್ ಆಗ್ತಾ ಇದೆಯಾ, ದಟ್ಸ್ ಪ್ಲೇಸ್ ಎ ಮೇಜರ್ ರೋಲ್. ಇಫ್ ಇಟ್ ಇಸ್ ರೈಸಿಂಗ್, ಹೈಯರ್ ಟೆಂಪರೇಚರ್ ಮೈನಸ್ ಲೋಯರ್ ಟೆಂಪರೇಚರ್. ಕ್ಲಿಯರ್? ಗೊತ್ತಾಗ್ತಿದ್ಯಾ? ದ ಡಿಫರೆನ್ಸ್, ದ ಡಿಫರೆನ್ಸ್ ವಾಟ್ ಎವರ್ ಇಸ್ ರೈಸಿಂಗ್ ಆರ್ ಫಾಲಿಂಗ್, ಏನ್ ಡಿಫರೆನ್ಸ್ ಇರ್ತದೆ ದಟ್ ಇಸ್ ಟಿ. ಗೊತ್ತಾಯ್ತಾ? ಅದಕ್ಕೆ ನಿಂಗೆ ಡೆಲ್ಟಾ ಟಿ ಅಂತ ಯೂಸ್ ಮಾಡ್ದ ಆ ಒಂದು MCQ ಕ್ವಶನ್ ಅಲ್ಲಿ. ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರ? ಅಲ್ಲಿ ನಿಮ್ಗೆ ಏನಂತ ಆಪ್ಷನ್ ಇತ್ತು? ಆಲ್ಫಾ ಇ ಡೆಲ್ಟಾ ಟಿ ಅಂತ ಇತ್ತು ಸ್ಟ್ರೆಸ್ಗೆ. ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರಿ ಅಲ್ವಾ ಆ ಕ್ವಶನ್ ಅಲ್ಲಿ? ಸೊ ಎನಿ ಡೌಟ್ಸ್? ಅಂಡ್ ಆಲ್ಸೋ ಸಮ್ ಟೈಮ್ಸ್ ಇನ್ ಫ್ರೀ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ವಾಟ್ ಇಸ್ ದ ಸ್ಟ್ರೆಸ್ ಅಂತ ಕೇಳಿದ್ರೆ ಏನ್ ಆನ್ಸರ್? ಸ್ಟ್ರೆಸ್ ಇಸ್ ಇನ್ ಫ್ರೀ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ 0. ಗೊತ್ತಾಯ್ತಾ? ಓಕೆ, ಶಲ್ ವಿ ಮೂವ್ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್?
Yes, sir.
Okay. See the next question. See, it's more or less the same question, but here what I am asking, ಇಲ್ಲಿ ಏನ್ ಕೇಳ್ತಾ ಇದೀನಿ? Here we are asking the stresses, but the thing is, the expansion is allowed in the rail at, determine the expansion allowed for the no stresses at rail. The coefficient of thermal expansion is given as 11 into 10 power minus 4 and E is okay. Okay, now you just you think that the rail, if the determine the allowed for no stress if coefficient of here the thing is one statement is missing. So yes, 80 degrees centigrade. Here one sentence is missing. The expansion allowed is 8 mm. So just include this. The expansion allowed is 8 mm. The expansion allowed is 8 mm in the rail at 80 degrees centigrade. So if the coefficient of expansion, all are the thing is same. The thing is here in this case, what the thing is, here there are two rails, but here ಈ ರೈಲ್ವೆ ಕಂಬಿಗಳ ಮಧ್ಯ the expansion is allowed to 8 mm. The expansion is allowed to 8 mm. Here there is no expansion. There is no expansion. But here the expansion is allowed to 8 mm. So what is the stress? Previous case ಇಲ್ಲಿ ಆಡ್ ಮಾಡ್ಕೊಳ್ರಿ. ಈ ಕ್ವಶನ್ ಅಲ್ಲಿ ನಾನು ಎಡಿಟ್ ಮಾಡಿ ನಿಮಗೆ ಕೊಡ್ತೀನಿ ಕೊಡ್ಬೇಕಾದ್ರೆ. Here the question is the expansion allowed is 8 mm. 8 mm. 8 mm in the rail at 80 degree. But in previous case, there is no stresses. There is no stresses. In this case, the 8 mm expansion is allowed. Then what is the stress? Change in stress. Change in stress. Then what is the case? What is the case? The thing is very simple. So what is delta L? What is delta L?
Alpha TL.
Alpha TL.
Yeah.
Delta L, you know that alpha TL. So now, what is strain? What is strain? Strain is change in length by
Original length.
Change in length by original length. Here 8 mm you have to subtract 8 mm in this case. If they are provision of expansion, you have to subtract the value in change in length. So it will become alpha TL minus 8 by original length is L. Original length is L. Original length is L. Now we know the alpha value, we know the T value, we know the L value, and minus 8 divided by L. And what is E? What is E? E, you know that by the relationship of Young's modulus. What is Young's modulus? This is the ratio of stress over strain. Now E will become sigma by E. So you just substitute the value sigma by E equals alpha TL minus 8 divided by L. You are getting sigma value. Please find the sigma value. Find the sigma value. What is sigma? Sigma equals E multiplied by alpha TL minus 8 by L. Yes, find Modi. You know E value. You know alpha value, you know T. T is temperature variation for 80 degree, same 56. And L is 32 meters. L is 32 meters. Yes, any answers? ಮಾಡ್ತಾ ಇದ್ದೀರಾ? Yes, put the values. E is 205 into 10 power 9. Alpha 11 into 10 power minus 4 multiplied by temperature is 56 degree, that is 80 minus 24. Length is 32. First ಇದನ್ನ ಮಾಡ್ಕೊಳ್ರಿ, divide by L ಮಾಡಿ, ಅದನ್ನ multiplied by E ಮಾಡಿ ಅಷ್ಟೇ.
Sir, excuse me, sir.
Yes.
Sir, I have doubt in the previous problem, sir.
Yes. What is the doubt?
E value you have taken 200 into 10 power 9 Pascal, no, sir?
Yes, ಹೌದು.
This given in the question E value or separate values?
Yes, they will give. ಅವರು ಕೊಡ್ತಾರೆ. ಅವ್ರು ಕೊಡ್ದಲ್ಲೇ ಇದ್ರೆ ನಿಮ್ಗೆ ಏನ್ ಮಾಡಿ, ಸ್ಟೀಲ್ ಆದ್ರೆ you assume 2.1 into 10 power 5. Okay, generally they will give for different materials. Clear?
Yes, sir.
ಅವ್ರು ಕೊಡ್ತಾರಮ್ಮ, ಅದೇನು ನಿಮ್ಗೆ ಪ್ರಾಬ್ಲಮ್ ಆಗಲ್ಲ.
Yes, sir. Okay, sir. Thank you, sir.
Okay. Yes, how much? ಮಾಡ್ಬೇಕು ನೀವು, ಏನ್ ಇದಕ್ಕೆ 1 minutes ವೇಸ್ಟ್ ಮಾಡಬಾರ್ದು. Yes, please try to get the answer. I think 75 MPa. Please try. Check. 75 MPa ಬರ್ತಾ ಇದೆಯಾ ಚೆಕ್ ಮಾಡಿ. Any one of you got the answer or different answers? ಬರ್ಲಿಲ್ವಾ? ಇಲ್ಲ ಕ್ಯಾಲ್ಸಿ ಇಟ್ಕೊಂಡಿಲ್ವನ್ರಿ ಯಾರುನು? Yes, ನೀವು ಮಾಡಬೇಕು, ಗೊತ್ತಾಯ್ತಾ? Please check this. Just substituting the values, you are getting 75 MPa. Shall I move on to next question? Okay. Yes, the question here, I repeat the thing. 8 mm. See, here the thing is, whatever the question, the same question for this, but here what he's asking, there is an expansion of alloyance. There is an expansion of alloyance is given. Rails are laid in such a way that there is a stress. There is a stress. So we have to determine the expansion. What is the equation for expansion? That's a direct question. What is the equation for expansion? What is delta L?
Alpha TLT.
Alpha TL. Alpha TL. Yes, you know alpha. You know T. You know L. Substitute. Please try to get the delta L. So alpha as this one. 11 into 10 power 4. T as 80 minus 24. And L is 32. Direct question. See, for confusing purpose, they will give so many things, but the ultimate aim is you have to determine the expansion. How much? 11 into 10 power minus 4 into 56 into 32.
19.7.
Yes, right? 19.7. Previous problem, have you got the answer? Sikka, Sagar, Chidanand, try ಮಾಡಿದ್ರಾ? Steps ಅರ್ಥ ಆಗಿದೆ ಅಲ್ಲ?
Yes, sir.
Yes, okay.
Sir.
So,
Sir, last problem delta L mm ದಾಗ ಇಡ್ಬೇಕು ಏನ್ ಮೀಟರ್ ದಾಗ ಕನ್ವರ್ಟ್ ಮಾಡಿಡ್ಬೇಕು?
ಯಾವ್ದಮ್ಮ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ನಾನು ಡೆಲ್ಟಾ ಎಲ್ ಕೇಳಿಲ್ಲ ನೋಡು. ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಇರೋದು
ಅಲ್ಲ ಸರ್, ಇದು ಅಂದ್ರೆ ಎಕ್ಸ್ಪಾನ್ಷನ್ ಕೊಟ್ಟಿದ್ರಲ್ಲ ಸರ್ ಅವರು -8 mm.
ಅದೇ ನಿಂಗೆ ಏನ್ ಹೇಳಿದೆ ನಾನು, ದಿಸ್ ಇಸ್ ದ ಪ್ರಾಬ್ಲಮ್ ಫಾರ್ ಪ್ರೀವಿಯಸ್ ಒನ್. 8 mm ನಾನು ಮಿಸ್ ಮಾಡಿದ್ದೆ ಅಂತ ಹೇಳಿದ್ನಲ್ಲ. ಸೊ ಹಿಯರ್ ವಾಟ್ ಎವರ್ ದೇ ಗಿವ್, ಬಟ್ ವಾಟ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್
Sir, in last problem, strain is equal to alpha TL minus 8 mm divided by L.
ಹೌದು.
Sir, ಅಲ್ಲಿ 8 mm ಇರೋದನ್ನ 8 ಅಂತ ಹಚ್ಕೋಬೇಕಾ ಅಥವಾ 0.008?
No. See, this is a very good thing you are asking. That is 8 by 1000, not 8 meters. 8 by it's a very good question. 8 by, you have this in mm, you have to reduce in That's why you are not getting answer. That's why I have stressed it so many times. Yes, you are right. Good. NS Patel is very good. The given thing is, I already told in the first problem, keep in 1 unit because the length in meters. Then obviously you have to put it in meter, 8 into 10 power minus 3. Right. Good. Sari Depa. Whatever you are saying is that is right. Yes. Please try with this. You are getting the answer now, at least. ಏನಿಲ್ಲ ರೀ ಎಲ್ಲದೂ ಒಂದು ಯೂನಿಟ್ ತರಬೇಕು ಗೊತ್ತಾಯ್ತಾ ಅದ್ ಮೀಟರ್ ಅಲ್ಲಿ ತಗೊಂಡಿದೀವಿ ಅಂದ್ರೆ ಆಬ್ವಿಯಸ್ ಅಲ್ವಾ 8 mm ಅಲ್ಲ 8 ಮೀಟರ್ ಅಂದ್ರೆ 8 into 10 power minus 3 clear any doubts shall I move on to next problem
Okay, sir.
okay ಗೊತ್ತಾಯ್ತಾ see this is where, that's why I have asked it several times I thought that at least okay ನೋಡೋಣ at least one of your friend is guessed the thing right ಅದ್ ನಿಮಗೆ ಗೊತ್ತಾದ್ರೆ it's really the thing is when you are identifying what you are doing whether it is right or wrong you are 50% pass so please whatever saying what I am saying if that is wrong you have to highlight the things clear so be careful when you are solving problem if you are doing a single mistake you are not getting the answer
Sir,
Clear?
can you equate it to 75 and show it?
yes 75 MPa right are you
Sir,
I
can
have
you
got
show
the
it?
answer
Sir, can you show it how it will come 75?
ಬರಿಯಮ್ಮ ಇದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಮ್ಮ ಈ ವ್ಯಾಲ್ಯೂ ಏನು ನೋಡಿ ಕ್ಯಾಲ್ಸಿ ತಗೋಬೇಕು 205 into 10 power 9
Yes,
ಇದನ್ನ
sir.
ಮಾಡ್ಬಿಡಿ ಆಲ್ಫಾ ಟಿ ಎಲ್ ಮೈನಸ್ 8/1000 8 into 10 power 3 ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ ಹೇಳಿ ಆಲ್ಫಾ ಇಸ್ 11 into 10 power minus 4
11 into 10 raised. Yes, sir.
10 power 5 minus 4 t is 80 minus 24 under 56
Yes, sir.
L is 32
Yes, sir.
minus 8 into 10 power minus 3 ಅದು ಎಷ್ಟು ಬರುತ್ತೆ ಹಾಕು ಡಿವೈಡೆಡ್ ಬೈ L is 32 ಅದು ಮಾಡಿ ಇದ್ರ ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡು
So it is
ಎಷ್ಟು ಬರ್ತಾ ಇದೆ
sir 125.
calculation part you just take care how much you are
Sir,
getting
it's 125. Sir.
125 okay so 125 all of you getting 125 please check the answer 125 or 75 or 130 please check the answer okay if it is 125 right so the options all options are wrong don't if all options are wrong don't go it ಅದನ್ನ ನೀವೇನು ಮತ್ತೆ ಏನೋ ಸ್ಪೆಷಲ್ ಆಗಿ ಏನೋ ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗಬೇಡಿ ಬಿಡಿ ಗ್ರೇಸ್ ಸಿಗುತ್ತೆ clear any doubts in MCQ it's a direct forward if you are all questions are wrong definitely you are getting grace if you hit any of the answers then you are losing the marks ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ
Yes, sir.
ಅರ್ಥ ಆಯ್ತಪ್ಪ
Yes, sir.
ಈಗ 75 ಅಲ್ಲ 75 125 ಆಪ್ಷನ್ ಅಲ್ಲಿ ಇಲ್ಲ ಅಂದ್ರೆ ಡೋಂಟ್ ಗೋ ಬಿಡಿ ಅದನ್ನ ಗ್ರೇಸ್ ಸಿಗುತ್ತೆ ಇಫ್ ಯು ಅಟೆಂಪ್ಟ್ ಯು ಆರ್ ಲೂಸಿಂಗ್ ದಿ ಮಾರ್ಕ್ಸ್ ಕ್ಲಿಯರ್ ಓಕೆ
Yes, sir.
ಎಸ್
So for minus 8, it will be coming below in denominator 32 or it will be after that value, sir.
for minus 8
So then the equation, sir, alpha TL divided by L,
in this equation okay
whether the minus 8 is outside the
no
factor value or
see
included, sir.
this is very important question the thing is what is trying change in length by original length right see change in length so this is the entire change whatever is a one thing so that is delta L minus 8 mm delta L minus 8 mm is single one
Okay, sir. Okay.
entire ಗೊತ್ತಾಯ್ತಾ ಅದನ್ನ ಸಪರೇಟ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಹೋಗಬೇಡ್ರಿ ಡೋಂಟ್ ಟೇಕ್ ಇಟ್ ಅಸ್ ಸಪರೇಟ್ ಥಿಂಗ್ ದಟ್ ಇಸ್ ಇನ್ಕ್ಲೂಡೆಡ್ ಇನ್ ದ ಬ್ರಾಕೆಟ್ಸ್ ಕ್ಲಿಯರ್ ಓಕೆ ಸೊ ಇದು ಬಂತ ಸರಿ ಇದೆ ಆನ್ಸರ್ 19.7 all of you got the answer
Yes, sir.
okay
Yes, sir.
this is the last type of question in thermal expansion rails are laid such that there is no stresses in them Please keep in mind. If rails are 22 meter long, then allowance is the linear expansion is 11. Here, the thing is temperature variation is asking. He is not given the another temperature. Initial temperature is given. So T equals T2 minus T1. T1 is given. So T equals T2 minus 24. He is asking the value of T2. He is asking the value of T2. See, the answers given are in temperature. What is T2? Now, what is the equation? Delta L equal alpha TL. What is delta L? He is given the delta L directly. What is delta L
8
given? 8 mm. So 8 into 10 power minus 3. Alpha value is given 11 into 10 power minus 4 into temperature variation. What is temperature variation? T2 minus 24 multiplied by length is 32. Please determine the value of T2. Yes, T2 find out ಮಾಡಿ ಅಷ್ಟೇ. How much you are getting T2? ಮಾಡ್ಬೇಕು, ಪಟ 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 ಮಾಡಬೇಕು. ಡೋಂಟ್ ವೇಸ್ಟ್ ಟೈಮ್. 2 minutes ಗಿಂತ ಜಾಸ್ತಿ ಒಂದು ಕ್ವಶನ್ ತಗೋಬಾರ್ದು. ಎನಿ ಡೌಟ್ಸ್? ಸಿ ಕೆಲವು ಟೈಮು ಏನಾಗ್ತದೆ ಕ್ವಶನ್ ಅಲ್ಲಿ ನೋಡಿ, ವಾಟ್ ಈಸ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ಟೆಂಪರೇಚರ್? ಯು ಹ್ಯಾವ್ ಟು ಅಬ್ಸರ್ವ್ ದಿ ಕ್ವಶನ್. ಸೊ ದೆನ್ ಆಬ್ವಿಯಸ್ಲಿ T2 is, you have to go for T2. What is the value of T2? How much? Yes?
46.7.
Yes, very good. 46.72 B. Okay, now I am coming to ellaru follow ಮಾಡ್ತಿದ್ದೀರಾ? All are following what I am saying? All are following?
Okay, sir.
Yes, good. Okay, now I will give the question like this 14th question. I just yes, this is the question. Yes, please try to solve this question in 5 minutes. I'll give 5 minutes. Please try to give the answer now. Just ನಾನು ಇಲ್ಲೇ ನಿಮ್ ಜೊತೆನೆ ಇಂಟರಾಕ್ಟ್ ಮಾಡ್ತಾ ಇರ್ತೀನಿ. ಆನ್ಸರ್ ಕೊಡೋದಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ ಇದಕ್ಕೆ. This is very very easy question because this type of questions we now just only we solved. A copper bar of length L is given. How much? 25 centimeter. Fixed at its ends. So second condition. And support can yield total delta is given as 0.01 centimeter. The temperature of bars rises by, so only one temperature, no problem, given 100 degree. Alpha is given, EC is given. That is the Young's modulus is given. Then what is the equation? We solved this kind of problem, right? What is the equation?
Alpha into T into E minus E into delta L by L.
Very good. That is the thing. That is, you have to apply strain. That is E. E equal change in length by original length. What is change in length? 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 Change in length is nothing but dl minus delta. dl minus delta is the change in length. Original length is L and this is E, right? So what is delta L? What is the equation for delta L in temperature stresses? Alpha T L minus delta by L. Now alpha is known, E. E in the place of E, what he is asking? He is asking stresses, right? So write sigma by E. Sigma by E. This is a basic stress concept. Now sigma equals stress, that is Young's modulus multiplied by alpha TL minus delta divided by L. This is the type of problem what we solved in previous one. How much you are getting? Please try to get the answer and also observe the unit. Since centimeter, okay. This is also in centimeter, but in previous case they are given in mm. We made a mistake and we just corrected in last. Clear? Huh? So here centimeter, fine, no problem. Temperature variation is directly given as 100 degrees centigrade. If the two temperatures are given, you have to take the difference. Yes, any doubts? Yes, what is the answer? What is the sigma?
16 into 10 square.
16 into 10 square. That is 1600 kg per
Centimeter.
So option D.
D.
So have a clear ಎಲ್ಲರಿಗೂ ಗೊತ್ತಾಯ್ತಾ? Clear ಆಯ್ತಾ concept? Any doubts in the concept? Any doubts? So ಏನ doubts ಇದ್ರೆ ಕೇಳ್ರಪ್ಪ. Temperature stresses. So how many kinds of the thing? There are two cases. One is free expansion and another one is fixity. In free expansion, thermal stresses are 0. In fixity, then only you are getting thermal expansion. So 3 equations you have to remember. So one is that is thermal that is change in length, that is delta L. Delta L equal alpha T L. Next stress sigma alpha T E. Next strain alpha T. Strain alpha T. Clear? Strain is alpha T. Next, applying the problems depending on given condition. What are the expectations? Directly they may ask DL, or directly they may ask sigma, or they will give the whatever the expansion, this kind of problem, and also they may ask temperature. Clear? So in this class we covered regarding temperature stresses, and it is a very, very important aspect. Any doubts? Any doubts? Any doubts?
No, sir.
No, sir.
Okay. So we just finished all these things. Failures, patterns. This is very, very important. Different types of stresses in materials, deflections, equations, and also we solved simple problems, elastic constants. This is very, very important topic. Here also you are getting very simple relationships, and also you may expect few MCQ questions. So these are the basic definitions. You know that. What is elasticity? This is the ratio of stress over strain within an elastic limit, or ratio of longitudinal stress to longitudinal strain. What is modulus of rigidity? The notations are very, very important. Elasticity is represented by E. Shear modulus or modulus of rigidity is represented by G, and bulk modulus is represented by K. So shear means shear stress to shear strain. Bulk modulus is a stress, longitudinal stress or direct stress, both are same, divided by volumetric strain. This is the basic definition, but you have to remember one more elastic constant. These 4 are very, very important features in elastic constants. These are the properties is responsible for material nature. Please keep in your mind elastic constants. What are elastic constants? E, G, K, mu. Modulus of elasticity, modulus of rigidity or shear modulus, bulk modulus, or Poisson's ratio. So very, very important. And sometimes in numericals they may expect the like, what is the Poisson's ratio for car? See, for carbon the bulk Poisson's ratio is 0 for car, 0.5 for rubber, 0.25 to 0.4 for elastic metals. See, this is very, very important for concrete. Generally in design, the Poisson's ratio will take in between 0.1 to 0.2. Generally will take 0.15. And also for mild steel, this is 0.286. And also this is very, very important. Poisson's ratio is greater for ductile materials than brittle materials. Sometimes you may expect a direct question. So please pick the correct or match the following. Ductile materials, greater Poisson's ratio. Brittle materials, like that. So generally mu is greater for ductile metals for brittle metals. Ductile ge just irtade. Okay. Next thing, relationships. This is very, very important aspects. So for this, I will just use the equation. You have to remember 2 equations, at least 2 equations. If you remember 2 equations, the third and fourth easily you can derivable. So what are the equations you have to remember? Please keep in your mind the 2 equations you have to remember while we are doing relationships. Or first, that is Young's modulus E, shear modulus G, or K, that is your bulk modulus, and mu. These are four are elastic constants and relationships. Now I'll write the relationship. You have to remember those relationships. That is E equal 2G into 1 plus mu and E equals 3K 1 minus 2 mu. See, please remember these two equations. If you remember these two equations, these remaining two equations we are getting from these two equations only. These two equations are base equations. The relationship between Young's modulus and shear modulus or rigidity modulus. The relationship between Young's modulus and bulk modulus. See how you can remember. It's a very simple thing. If you see 2G is rising, 2G rising, 2G, you just remember like 2G scam. There's a lot of whatever the thing. There is a positiveness in this particular thing in the scam. So that's why 2G 1 plus mu. What is the loss? 3K loss. 3K 1 minus 2 mu. So 2G positive 1 plus mu. 3K negative 1 minus 2 mu. 1 minus 2 mu. Using these two relations, we can get these two relationships. So first, please keep in your mind, if I'm talking about relationships, you keep these two equations in your mind. Using these two equations, we can get these two equations. How? We can see in the MCQ questions, these two will appear as an MCQ questions. Generally, they will ask. Okay. So here, how we can arrive? If you take mu, if you eliminate mu, you are getting this equation. If you eliminate, how to eliminate mu? It's a very simple thing. If you want mu, what you have to do? You have to multiply these two things. That is 2G plus 2 mu G equals E. So you bring this right, 2G minus E, 2G minus E equal minus 2 mu G. What happens if you take minus outside? It will become E minus 2G, minus get cancelled. So you are getting 2 mu into G. So you want mu, then E minus 2G divided by 2G. So keep this equation 1. Similarly, write this equation as mu. What you are getting here? 3K minus 6K mu equals E. If you want mu, right? So 3K minus E equals 6K mu. If you want mu, 3K minus E divided by 6K. Now equate these two things. If you equate these two things, E minus 2G divided by 2G, which is equal 3K minus E divided by 6K. Now cross multiply these two things, cross multiply moduli. Finally, you're getting E. How you're getting? See, if you multiply this 6K E minus 12K G equals 6K G minus 2 EG. Now, if you just try to eliminate the things, whatever you are getting, finally, you are getting this particular answer, 9 kg divided by 3K plus G. Okay. So if you eliminate, next, if you take ratios of this, you are getting this one. If you take ratios, you are getting the next one. So, and also finally, the thing is, you have to remember these equations. These two equations are very, very important. If you eliminate mu, you are getting this equation. If you take the ratios, of relationship between G and K, you are getting this equation. So while we are solving MCQ part, we will concentrate on these questions. And also the main thing is, this is very, very important. Generally, they will appear in MCQ question. For material, homogeneous and isotropic, the number of independent elastic constants are 2. For orthotropic, the number of elastic constants are 9. For anisotropic, the number of elastic constants are 21. Generally in MCQ question, They may ask like, what are the elastic constants for homogeneous isotropic material? They will give us 2, 3, 4. Don't take like all whatever Poisson's ratio, E, G, K, or don't think like 3-dimensional 3. No, the elastic constants for homogeneous material, you are getting only 2. For orthotropic, you are getting 9. For anisotropic, you are getting 21. This is the thing. Generally, they will ask directly in the examination. So thermal stresses and thermal strain. Today, first thing we have just discussed regarding this. These are the. Yes, sir.
Keshav,
Okay.
sir. ಅದು
Oh, okay,
7
okay,
o'clock.
sir. Okay.
7
Okay.
o'clock ಆಯ್ತು. Thank you
Thank
very
you.
much.
So in next class, we will do some more numericals associated with this. Okay. And also we will do a very, very important topic, principal stresses and Mohr circle, how to draw and all. Okay. Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.